Mueller Hinton Agar. It might just look like a simple plate of jelly, but believe me, it's one of the most important weapons we have in the entire field of microbiology.
So take a look at this. What you're seeing here is literally the gold standard for what's called antimicrobial susceptibility testing. This petri dish is ground zero for figuring out which antibiotics are going to work against a specific bacterial infection. And, just as importantly, which ones won't. So here's how we're going to break it down. First, we'll cover what Mueller Hinton Agar actually is. Then we'll dig into why it's the go-to standard for testing. After that, we'll check out its super versatile modifications, and we'll wrap it all up with the key takeaways.
And that really brings us to the big question for today, right? Why this specific agar? Out of all the options, what makes Mueller Hinton the #1 choice for labs all over the world when they're running these critical antimicrobial susceptibility tests, or AST? Okay, let's start with the absolute basics. What exactly is this stuff? At its heart, Mueller Hinton Agar is just a very specific, very standardized recipe. We call it a non-selective medium. Now, what that means is it's designed to let pretty much any common bacteria grow on it. It doesn't pick favorites. And that's key. It creates a level playing field so we can see exactly how different antibiotics affect the bacteria without any other variables messing up the results. All right, now let's get into the nitty-gritty of what makes this agar so incredibly reliable and why it became the global standard in the first place. So what's the secret sauce here? Well, first off, its composition is meticulously standardized. It's got things like beef extract and casein hydrolysate, which is basically just a protein from milk broken down into nutrients, and it has starch to soak up any toxic stuff the bacteria might produce. Critically, these ingredients feed the bacteria without interfering with the antibiotics. Second, the pH is kept stable, right between 7.2 and 7.4. This is so important because if the pH is off, it can actually change how an antibiotic works and give you a totally wrong result. And finally, all of this standardization leads to one thing: reproducibility. And this is the real kicker. It means a lab in London can get the exact same result as a lab in Tokyo. That allows doctors and scientists all over the world to fight disease using the same reliable data. And it doesn't stop there. Another huge deal is that it has really low levels of certain chemicals, like thymidine, which could otherwise interfere with some common antibiotics. Plus, its texture, that porous, gel-like consistency, is totally by design. It allows the antibiotics to spread out or diffuse in a really even and predictable way, which is essential for getting an accurate measurement. And to top it all off, it works for most of the clinically important bacteria you'd encounter, and it lines up perfectly with the guidelines from big organizations like the CLSI, the folks who set the global standards for lab testing.
But here's where it gets really cool. That standard formula, that's just the starting point. One of the greatest strengths of Mueller Hinton Agar is just how adaptable it is.
You see, while MHA is great for most everyday bacteria, some are a lot more demanding. We call these fastidious organisms. Basically, they're the picky eaters of the microbial world, and they need extra nutrients to grow. And the standard MHA recipe is the perfect foundation to add those supplements to. For instance, you can add about 5% sheep's blood to create a richer medium that supports picky bugs like Streptococcus pneumoniae. Now, if you take that blood and you heat it up, you break open the red blood cells, which releases even more growth factors. This creates something called chocolate agar. And no, there's no actual chocolate in it, it's just the color. This version is what you need to grow really tough bacteria like Haemophilus influenzae. But these modifications aren't just about feeding picky bacteria. Sometimes you have to tweak the actual chemical environment of the agar to get an accurate result for a very specific antibiotic test. A great example is testing for methicillin resistance in Staphylococcus. To do that properly, you actually have to add extra salt, sodium chloride, to the agar. But on the flip side, if you're testing certain antibiotics like aminoglycosides, you need to use a special low cation formula that has less calcium and magnesium because those ions can get in the way of the drug's activity. It's all about creating the perfect test conditions. And the versatility is just incredible. I mean, the MHA platform can be pushed even further to handle a huge range of microbes that go way beyond your typical aerobic bacteria. By adding just the right nutrients and growth factors, you can create special versions for testing anaerobic bacteria or for really slow-growing and dangerous pathogens like Mycobacterium tuberculosis, and even for testing the susceptibility of yeasts like Candida. It's a truly flexible, powerful system. Okay, so after looking at all of that, let's pull it all together and talk about why this really matters.
So here's the bottom line. Mueller Hinton Agar is the universal standard for a very good reason. Its reliability isn't an accident. It's engineered right in with that standardized formula and stable pH. And maybe its greatest strength of all is its incredible adaptability. It's the solid foundation that you can build on to test a huge variety of microbes, from bacteria all the way to fungi.
And this brings us to one last thought. Mueller Hinton Agar has been a workhorse for us. It's served us incredibly well. But as we all know, we are facing this growing, massive challenge of antimicrobial resistance. And it really makes you wonder, what's next? What will the next generation of susceptibility testing look like? Is it going to be another modification of this trusted standard or something brand new? The answer to that is going to be absolutely critical in our ongoing fight against infectious diseases. Thanks so much for joining me.